G'day, welcome to my channel. This video is going to be focused on the type of lathe I purchased and the reasons why I went in this direction. I hope this video will give insight to those who are new to hobby machining, are a bit unsure or confused about what machine would suit their needs. The machine I have is the largest bench lathe that SIG offers. It's the SC10 Pro. The Pro bit means that it came fully assembled on a stand and included a DRO, a coolant system and a few other bits and pieces. In its category, it's about the same size and weight from some of the other brands out there, and I'm sure their quality is just as good. When I first started looking at different lathes, it was very confusing and frustrating on what to buy. All the different specifications, sizes, features and quality. My initial thoughts were something small and compact, but ended up buying the biggest bench lathe they make. What made my mind up after all the research was that you can make big things on a large lathe and you can also make very small things, meaning that with the correct tooling I can turn stock 305mm in diameter all the way down to about 1mm in diameter, and between the centres it's about 700mm long, and having a 38mm spindle bore gives me great scope for many projects. Another factor that you must consider is space in your workshop, or with some others the kitchen or bedroom. That can depend on the type of partner you have. But we will stick to the workshop. I am fortunate. I have room in my garage, so size didn't really matter, and in the end I am very happy with what I ended up with. Certain features on the lathe were very important to me, but maybe not so much to others. My main features that I required were power feed on the both X and Y axis, induction hardened bedways, thread cutting ability, a DC motor and metal gears. My recommendation is go for the lathe that has the features you desire and the size that suits your space. Tooling is another factor to consider. Most lathes will come with a 3-jaw chuck, set of cutting tools, tailstock centre, a spindle centre, travelling and fixed steadies and a few other bits and pieces. This is generally enough to get you started cutting, but as you progress you will need to buy more tooling. I will do another video on tooling and show you how I went about building up my tool stock. Now let's have a close look at the machine. Let's have a look at the controls on the face of the headstock. Most bench lathes will have similar controls. To power up the lathe, simply pull and twist the emergency cut-off switch, just like that. To cut the power out, hit the switch and all power is cut. To the right of the switch, you have a digital display that will show you the forward and reverse and the RPM of the machine. Below that are the forward and reverse switches, which you can select these switches when the machine is running at low RPMs. And below that are the on-off switches. These stop the power to the motor and not the machine. You will use these switches for thread cutting or reverse cutting, and it's a very simple system. And below here you have a control for your RPM. Over here is the coolant on-off switch. If you're running coolant, you'll have a switch somewhere to start the pump. Below you have the gear change levers for thread cutting and carriage cross-slide feed rates, which control a selection of gears located behind this cover. For general cutting, I set them to A1, which gives me a rather slow feed rate when using the power feed. This gives me a pretty good surface finish. Let's have a look at the gear change box. Most bench lathes will have a gear change box of some description. On this machine, I can open the cover door and have complete access to the change gears. The motor is located back here, and via a belt it provides rotational force to the machine. The gears here are set up for metric threading. To change to imperial threading, I need to swap over these two gears. They're easy to mesh and adjust. There is also a gate on the door so I can insert long rod through the spindle. It is secured in the chuck end, but at the back end it will need some sort of support. You can attach a device known as a spider, which will hold the workpiece, or you can use plastic wedges for support. You need to keep all gears lubricated. A few drops of oil on the teeth is all that's needed. Your smaller bench and mini lathes might come with plastic gears, and they're okay. If you're not happy with them, you can always swap them out with metal gears. The gears are simple to identify. They are not sorted by diameter, but by the tooth count. If you want to know where all the noise of your lathe comes from, it's all in here. I'll just run it so you can hear it with all the gears rotating. Now what I'll do is I'll disengage all these gears and run it again, and you'll see how much quieter it is. So all your noise comes from the gears. Let's have a look at the DRO, or digital readout. When my lathe arrived, the DRO was mounted on the top of the headstock, back here. It probably wasn't the best place as it got in the way of the chuck guard, so I made a bracket and mounted it off the machine. I now have a lot more space on the headstock for tooling. The DRO displays the precise position of the cutting tool along the machine's X and Y axis. It's like a digital mapping system of where the tip of your cutting tool is in relation to the part. It uses lineal scales mounted to the machine to track movement independently of the lead screw. This eliminates errors from backlash and wear. This results in more accurate and repeatable cuts. DROs generally have a lot of features, many of which you will probably never use. It's like using a scientific calculator. The main features are that it is absolute, which means that it will always remember where the tool is located even if you switch it off. You basically have an origin or home start point. It can be used in both metric and imperial measurements and can find the centre of your part. I can't show you where the carriage scale is because it's fixed at the back of the lathe bed. This is the lineal scale for the cross slide. It's very similar to the carriage scale. The scale or encoder is located under this protective cover and moves with the cross slide. The mated encoder below is fixed to the carriage, and as you move the tool, the encoder sends a signal to the DRO's display unit. If you think you need a DRO, then order it with the machine assembled. The installation procedure can be quite time consuming and you need to get it right. Here on the right side of the headstock, you can see the Gearbox oil filling port plug and the oil sump drain plug. I change the oil about every 6 months. I place a small tray under here and remove both plugs. I let it sit overnight and fill it back up with clean gear oil. The drain plug has a glass window with a level line. This is the lead screw. It's a threaded rod that extends the full length of the machine, and its primary function is to cut screw threads with high precision by moving the tool in a fixed distance for every rotation of the workpiece. That's where the gear selectors come into play. I have these protective spring steel covers on both sides of the carriage. The lead screw is a critical part of the lathe and does need protection. A damaged lead screw is not good. I will do a detailed video on single point threading in the near future, but I will say cutting threads on this machine is not difficult. This is the feed rod under here, and it's used for general power feeds on the carriage. It spares the lead screw from excessive wear. It also has a slip clutch for crash protection. Some feed clutches are designed as a slip clutch. This protects the machine by disengaging automatically if the carriage hits a hard stop, preventing damage to the gears and other components. It's a built-in safety feature and it can be adjusted here. And up top here, underneath the way, is the rack for the carriage handwheel. There is a set of gears in the carriage that engage this rack so you can move the carriage by hand. Let's look at the spindle and work holding. Looking at the headstock face on, you can see the spindle from both sides. It's held in place by heavy duty bearings on each end. The spindle is driven directly from the DC motor via a belt. The benefit of a DC motor is it offers high starting torque and variable speed control, so I can set the spindle speed to wherever I want. It has a 38mm bore, which means I can pass stock up to 38mm right through the headstock. The spindle taper is Morse taper 5. The locking mechanism for the cam lock spindle is D14, which is pretty much a standard fitting for a lathe of this size. You can see here that the spindle nose has an ER40 collet chuck fitted. Here is the spindle nose fitted with a 3-jaw chuck, or I can even put a 4-jaw chuck on. It only takes a few minutes to change over, and the chucks are secured by 3 cam studs. It's important that you wipe clean all mating surfaces prior to fitting. Any work chips or other debris can offset the mating, and that will reflect on your workpiece. Here you can see the cam locks on the spindle nose and the cam studs on the back of the chuck. Whenever changing chucks, it's a good idea to place a wooden board on the ways. A chuck falling on your ways can cause damage. When you buy your lathe, it's a good idea to punch mark the positions for the cam locks and studs to ensure repeatable mounting. I also have my chuck punched marked for the jaws. You normally get 2 sets of jaws for chucks, so you can hold work both internally and externally. A chuck key will come with your lathe. The cam locks, when tightened, pull the chuck back face into the face of the spindle nose and secure it firmly. Let's look at the carriage. This is the carriage. It travels along the bedways, and this is where all cutting is performed. The face of the carriage is called the apron. This is the saddle. The saddle is the part of the carriage that rides on the bedways. It supports the cross slide, which in turn supports the compound and the tool post. Starting up top here, you have the tool post, which is where all cutting tools are secured. This tool post allows me to cut on a wide scale of angles, so I can cut lineal and face cuts by simply rotating the unit. The compound, or top slide, doesn't have a power feed and is manually controlled by a hand wheel. It's primarily used for cutting tapers. It is a scale that is marked out in degrees to set your desired angle of cut. You can also use the compound for small detailed gentle cuts. This is the half nut lever. For threading, the half nut lever is used. When engaged, it clamps onto the lead screw and enables the carriage to travel along the y-axis. The power feed select, to the right of it, must be in the neutral position when threading. This is the power feed clutch. The power feed clutch is the disconnect between the feed rod and the apron drivetrain. It is only used when feeding using the feed rod to power either the carriage feed in the Y direction or the cross slide in the X direction. It is not used for threading operations. Let's look at the tailstock. The tailstock is located on the far right of the machine and travels along the bedways. Its primary functions are to provide support for long and slender workpieces, preventing deflection from the cutting tools. It also secures other tools for drilling, reaming, internal and external threading, centering and other functions. The tailstock is secured by a cam lock. It has a turn handle that operates a spindle. On this machine the spindle bore is Morse taper 3 and it can be locked into position. It can also be used for setting tool height. It's important that the tailstock is in perfect alignment with the headstock spindle, which will prevent cutting tapers. To secure stock, simply advance the tailstock close to the workpiece, lock it in place and gently advance the centre into the pre-cut hole of the part, then locking the spindle. It now provides a rigid part ready for machining. To align the tailstock with the headstock spindle is simple, and it's something that you will need to check on occasions. Incorrect side alignment will cause tapers on parts. With the headstock spindle wiped clean, I insert a Morse taper 5 centre. I bring in the tailstock centre to just touch the point of the spindle centre. You need to look from above to see if they match. Also look from the front. Look at the lines outside to see if they align. To adjust the side deflection, there are setting screws on each side of the tailstock. Back one out slightly and tighten the other until the points align. If the height does not align, then you will need to shim the tailstock. Height alignment isn't really that important. There are various methods for setting tool height. Using the tailstock with the centre is one of them. The cutting tip needs to be centred with the spindle, especially when facing, otherwise you will end up with a small part of the centre that won't be cut. You can see here that this tool tip is low and will need to be adjusted. That's a simple task. When I make any alignment adjustments, I make a test cut. I keep this piece of aluminium bar stock on hand and use it to take test passes. I then measure both ends with a digital outside micrometer. I need an accurate read. You can see here that my cut is out by 1/2 of an inch over 6.75 inches. That is 0.127 millimetres, about 1/8 of the thickness of a human hair. I'm not going to touch that, I'll leave that alone. Generally when you buy a lathe, it will come with a fixed and travelling steady. These are used to support stock when it's too large to fit in the spindle bore, too long to secure safely in the chuck, and cannot be used by the tailstock. It acts as a rigid support to prevent flexing, bending or vibrating during machining operations, allowing for more accurate and precise cuts and a smoother finish. The steady can be fixed to either side of the carriage. Let's look at the fixed steady. It is secured under the bedways by a simple but secure clamping fixture. As you can see, I have it set up with a rather large rod of scrap gold that has been taking up space in the garage. I think it's 18 carat. No, it's 24 carat. It doesn't matter. This setup allows me to centre drill the face so I can support it with the tailstock. I wouldn't be able to get the hole centred any other way. It also allows me to face and chamfer cut. With the use of a dial indicator, I can make adjustments with the 3 bronze fingers to centre the stock with the centre line of the spindle. As you can see, it's quite a simple setup. Let's look at the travelling steady. As the name suggests, it travels with the carriage. It's bolted to the saddle and supports a long workpiece close to the cutting tool as it moves. It's ideal for long slender parts where support is required the entire length. It applies a counteracting force. As the cutting tool pushes the workpiece away from the centre, the travelling steady counteracts this force, preventing the workpiece from bending or lifting. It only has 2 adjustment fingers, and are adjusted just like the fixed steady. You only need light pressure just touching the stock. I have here a piece of scrap 950 grade platinum. I think I used it as a tomato stake last year. It's all I had on hand for this demonstration. You can see here without support, the stock can be pushed away from the cutting tool, resulting in inconsistent cuts. These steadies are ideal for securing long rod stock for making long threaded rods like replacement lead screws or turned shafts. A faceplate is another accessory that should come with your lathe. This one is still new. I've never used it before and have only now just unpacked it. It's made from cast iron, which in my opinion is good. It is secured to the spindle by using the D14 mounting system, the same as my 3-jaw chuck and collet chuck. You can see a pattern now on how work holding devices are attached to the spindle. Very convenient. The faceplate is used for securing irregular shaped workpieces for machining. Something like this. Or this. Or even this. The workpiece is usually attached to the plate by using bolts and clamping fixtures. This clamping kit that came with my mill would be useful. There are many ways to fix a workpiece to the plate. You need to do a bit of planning prior. You can use a tailstock to hold your workpiece in place. You can see here that I've used a drill chuck to extend the length of the tailstock spindle. Or use clamps like this. Then you can play around with your clamps and nuts and bolts. You just need to make sure that whatever you fix to the plate won't fall off or get in the way of the cutting tool. Generally, you will need to match the plate with the spindle. As you can see, my spindle does not have much run out. It's pretty good. But the faceplate, it's a different story. Have a look at this. It's way out. It's not flat, but I expected that. I'll make another video on how I will fix this problem. It's too much to explain now. This tool post did not come with a lathe. It came with a standard tool post that was a bit slow and annoying to change out cutting tools. This is what you call a multi-fix tool change post. It's very smooth and easy to operate. I have various cutting tools pre-installed in these tool holders, and swapping them out is very simple. To fit the tool post, I needed to machine a new shaft to fit. There it is. It's a custom job. I cut the diameter of the shaft so that it would be in very tight tolerances to the tool post, giving me a fit without any side play. I also used a bearing washer on the clamping nut, which reduces the amount of force to lock it in place. The new larger handle and nut was called for as the original was too small for my hands. That was a job done on both the lathe and the mill. It worked out being a successful job in the end. If you're going to buy a quick change tool post, then have a look at what else is available. There are also wedge and piston types. These all work in a similar manner. It's just preference. They're all as good as each other. The protective cover and mounts for the cross-slide lineal scale needed to be replaced. They were just too flimsy. Some aluminium angle and brass rod was all that was required to make the fix. I don't want to damage anything under here. Like on the tool post, the tailstock cam lock lever was also too small, so another was fabricated and a bearing washer installed. The spindle lock was also replaced, along with the nut. These are way covers. Lathes don't normally come with way covers. I like them as they provide some protection and keep most of the chips off the ways. They don't get in the way of machining operations. You have to make them yourself, a great little project. These are simple. The covers are sandwiched between some aluminium angle and flat bar frames, and some high strength magnets attached. Clearance needs to be cut so they sit low but don't ride on the ways. They are easy to remove and install. I bought the covers from eBay. They come like this. You just need to cut them to length. To provide maximum protection, I suggest that you give them about 1 inch overhang each side of the outer edges of the ways. The machine stand and rear guard are of a very robust construction. Quite thick sheet steel was used, which is good. I'm always concerned about vibration and noise. High density PVA foam was adhered to the rear of the guard and under the stand. It has good vibration and sound reducing qualities. As I don't run coolant, rubber matting was laid on the stand tray cut to the imprint of the machine. It also has sound reducing qualities, but also gives some protection if a tool or part was dropped. When the machine arrived, the cabling for the lamp and lineal scales was way too long in length and was not managed how I would have expected. Some cable management was applied and now it's all neat, tidy and out of the way. The last thing you want is something heavy falling on one of the lineal scale cables and ripping it out. And the only other modification that was made was to locate the DRO off the machine. Overall, I'm very pleased with this machine, and the modifications were not critical to the machine's operation. They were just my preference. It would still have operated just the same. Let's have a look at the 3-jaw chuck. Looking at the face, it's made up of a body and 3 jaws. These are inside jaws, but they can also be used as outside gripping jaws. You will notice the 2 steps. A set of extended outside jaws should also come with your chuck. On its side you can see the gyro, or pinions. There are 3 of them. This is where the chuck key is inserted to rotate the scroll. On the back side there is a back cover, and under the cover, inside the body, there is a tooth disc that has a scroll machined into the face. It's called a scroll plate. These are the cam locks. They secure the chuck to the spindle. There are 3 of them. As you can see, when the jaws are fully closed, I can only secure stock of greater than about 3.5 millimeters. The chuck key is used to move the jaws in and out and secure stock at 3 contact points, just like the chuck on your hand drill, just a little bit larger. It's important to remember to remove the chuck key before starting the machine. Leaving the key in would cause a major disaster. You can use a spring-loaded key that cannot be left in the gyro. On my machine, and many others, the chuck guard will not allow the machine to start if it's not fully closed. If the key is left in the chuck, then the guard will not close. It's a safety feature. You'll notice that on occasions I have removed the chuck guard. It's for filming purposes. I just can't get the camera in there, and I always reinstall the guard after. When you first buy your lathe, punch marking the chuck to the spindle is good practice. This ensures a repeatable fit. I don't have a ring-shaped part available, but I do have this pickled onion jar lid. Let's pretend that it's a ring. The ring is secured by turning the jaws out. You can see that the cutter can safely remove material from the outer sides and the face. Removing the jaws is simple. Just wind the spiral out until the jaws are free. You'll do this when it's on the spindle, so a good idea to place a piece of wood on the ways to prevent any damage. The jaws will drop out. This is the spiral plate, and underneath are the teeth that the pinions engage so the plate can be rotated. You can see that they match the interrupted spirals on the jaws. Watch now as I advance the plate. You can see the beginning of the spiral. Each jaw is matched to the body. You can see this is number 1. And number 2. To install the jaw, start with number 1 and rotate the plate until you find the spiral start. Then back it out clear of the channel. Insert the jaw and hold it in place, then advance the spiral past the jaw so it has full engagement. Keep advancing to the number 2 channel and do the same. Finally, the number 3 jaw. These outside jaws also have 2 gripping surfaces. These are used for stock that is too large in diameter for the inside jaws. This allows you to machine all surfaces away from the jaws. Be mindful of the exposed areas of the jaws when the machine is operating. This is the collet chuck. On the lathe, its purpose is to secure collets for work holding. It has a D14 mounting system. A collet nut pairs and secures a collet to the chuck. Normally they come with a fixed nut, but I prefer this type as it has a bearing which reduces the amount of rotational movement required to secure the collet. The collet and stock doesn't rotate when tightened. It's like a direct clamping force. I do prefer to use collets when possible, as they have more surface gripping area than the 3-jaw chuck, and you are not likely to mar the stock. Collets come in various size groups. This is an ER40, which means that the outside major diameter of the collet is 40 mm. The ER stands for Elastic Rego. It's from a company called Rego Fix in the 1970s. When fitting collets, it's important to wipe clean all contact surfaces on the chuck, nut and the collet. Any debris like metal chips caught in these areas can affect the accuracy of your work. Where possible, any stock should be inserted into the full length of the collet to ensure full clamping, as they are slit from both ends. To install a collet, just angle the collet and snap it in place of the nut like this. The nut is then screwed onto the chuck, about a full turn. Then you place in your stock and hand tighten it in. You now use the wrenches to fully secure the collet and stock. Notice that the bearing and the stock do not rotate. Common collets range from ER8 to ER40. The ER40 collets have a clamping range from 2 to 26 mm. If I need anything smaller, then I can use my ER16 collets. I have sets of ER40, 32, 25 and 16. The smaller ones are used mainly for my mill. When you buy your lathe, I recommend that you buy a set of collets, probably ER40 or 32. You won't be disappointed. The ER16 collets can grip stock as small as 0.5 of a millimetre. Let's have a look at machine mounting. It's important that your machine is securely mounted. Having a machine that moves around or is not securely fastened can lead to serious injury and damage to the machine. It also helps to eliminate vibration. Any vibration can be transferred to the dimensions and quality of your machining. If you don't have a stand, then it will need to be fully secured to a bench top. A lathe needs to be positioned correctly. You'll need to have access on the headstock side so you can open the cover door, have access to the gears and be able to pass stock through the spindle. You also need to have space behind the machine. Don't jam it up against the wall. The right side doesn't really matter, just enough room to slide the tailstock out. This machine was already installed on the stand and came on a pallet. I am tall, so the height was just a tad too low for my liking. I made a base from structural timber. Biscuit joined pieces of this stuff together to make a slab. It was fixed to the floor with some pretty heavy duty dynabolts. It was about the same height as the pallet the machine came on, which was good. The base of the stand was marked out and the machine positioned onto the base. Levelling was checked and full-length aluminium flat bar was used as shims. The garage floor has a gentle slope out to the door. That's normal. The machine stand was fixed to the base by 8 heavy-duty coach bolts. It's quite solid. Having a timber base is quite good, as timber being dense helps to reduce vibration. It has been on the base for over 2.5 years now, and there has been no change in its level. I've cut the water off in the street, so I will use this glass of vodka on the top slide to show any vibration when I run the machine. Looks okay to me. Let's look at basic maintenance. Whatever machine you buy, it's going to require some ongoing maintenance. This is what I do, but you will need to refer to your maintenance manual. Let's look at the ways. These are a critical part of the lathe. They are generally machine ground for flatness. These are induction hardened. That is, the surface areas have been induction heated and then quenched. That makes them extremely hard and wear resistant, which will help to maintain precision. They are not likely to be distorted. After using the machine, the ways should be wiped clean and a small amount of way oil applied to all surfaces. It's a very thick, sticky oil that seems to cling without running off. It helps the carriage to move smoothly and will protect them from corrosion. All other bare metal parts should be wiped with machine oil. The lead screw will need a small amount of oil. Just apply a few drops on the top and run the machine. Other threaded screws will need lubrication. like the cross slide and compound screws. The rack for the carriage handwheel will also need some oil. I insert the oil spout in here and lubricate the small gear that runs on the rack. I can't show you on the camera, it's hidden. I then run the carriage up and down the bedway. The gears will need a few drops of oil. This will ensure a smoother run. Don't ever put anything on the belt. If you have a gearbox with a wet sump, then refer to your manual about when to change oil. You will find these button oilers located around the machine. You just push the nozzle of the oil can against the ball and squirt some oil in. There are other areas to look at, like adjusting the gibs. You can see them here, and setting correct tension on the gears. That will be another video. When the machine is not in use, I cover it with an old bed sheet. Dust can be a killer to these machines, especially if you are wood sanding or sawing. Best to prevent any of this landing on your fresh oiled surfaces. So we've been through many aspects of the lathe. Most of the bench lathes out there will be very similar in operation. There are a few other points that need to be highlighted. It's all good to go out and buy your machine, set it up and have a bit of a play. If you have the knowledge and experience of these machines, then I guess that will be okay for you. But what about the newcomer, like I was? How do we get all this knowledge to operate a lathe safely and to make parts with confidence? There are a lot of great content creators on YouTube making some really amazing stuff. These people have lots of experience and knowledge. If you are just stepping into this world, then I suggest that you do some research. Search the net, watch YouTube, talk to experts, maybe even enrol in a basic machinery course. I know that TAFE offers a short night course here in Sydney, a couple of nights a week for about 2 months. A great way to start, and you will be taught by experts. It'll give you a good head start. But there is something that I recommend, and I know that you will think I'm a bit old-fashioned, but buy some books, like these basic lathe workbooks, written by experts in layman's terms. They cover many areas like tool holding, tooling, parting, turning, threading, and many others. These are great startup books, lots of information and fairly easy to understand. They are authored by experienced machinists from the UK. Another book is the Machinery's Handbook. This one is old, a 1978 20th edition. It probably belongs in a museum. I think they are up to about edition 33 now. It's loaded with all sorts of technical information like thread types, gearing, weights and measures, different metals, speed and feed calculations, and a whole lot more. A great buy, but not really necessary. Maybe later. I think the latest one is about $280 on Amazon. They call it the Machinist's Bible. Here is another one. It's Roebuck Zeus Precision Charts. They are from the UK. These data charts and reference tables are great for quick reference. They have loads of handy information, like standard drill sizes in metric and imperial, threading and tapping charts, metal hardness tables, conversion factors, Morse taper sleeves, sine and tangent tables, calculating angles, you know, all those logarithms and geometry from your school days. Yes, it's coming back to bite you in the butt. The charts are laminated. They are hard wearing, pretty hard to damage. Just keep them next to your machine for quick reference. You can pick them up on eBay or Amazon. They're not that expensive. You can build a small library and maybe keep them in your favourite safe space, where you can have quiet alone time gaining knowledge of your newfound interest. Sourcing metal stock is easy. I try to avoid eBay. It's quite expensive. I purchase from a local metal supplier called Edcon Steel. They are reasonably priced and have a lot of round and hex stock in brass, bronze, aluminium and various grades of steel, and they cut it to your own length, and they also deliver it to my door. I also have an aluminium supplier not far from home. It's like a warehouse supplying to tradesmen. They have an offcut area, and there is always lots of different offcut sizes on hand. They basically give the stuff away. I suggest you practice with aluminium. It's much cheaper than brass or steel, and you'll find it's quite easy to machine. When purchasing your machine, I strongly suggest, where possible, that you go to a shopfront supplier. You'll always have someone to answer any questions, and their stock is usually on display, so you can get a better understanding of what you want. They can also help you with advice. You can also do a bit of bargaining when you buy your machine. They can always throw in some other tooling or accessories. It's just so much better than ordering online. Let's talk about safety. Safety is something that you must be aware of at all times. Even the smaller machines can cause serious injury if you don't follow simple safety procedures. Make sure the machine is fully secured. Always wear safety glasses when the machine is operating. If you have long hair, then bundle it up. Don't use fabric rags when the machine is running. If caught on the spindle, they can drag your hand in. Use paper towel instead. It will just break up. Also, best to work in short sleeves. Remove all rings, watches and dangling jewellery. Keep your work area free of clutter, chips and tools to prevent slips and hazards. Also know the location and function of the emergency stop button, and remember, it cuts the power to the motor and not the machine. Don't wear gloves that are made of leather, cotton or other fabrics. Again, if the machine grabs onto the glove, then your hand will go with it. I like using the latex type gloves. They protect your hands from oils and chemicals, and you can have full dexterity. They're a lot safer. Never remove long stringy chips with your hands. Use long tweezers. This stuff is sharp and strong. If caught, it can cause serious cuts to your hands. For the smaller chips, like from brass, use a brush or compressed air. Make sure you have good lighting. You really need to see all detail. Your machine will come with a chuck guard. It's best not to remove it. It's there for a reason. I know that when filming I had to remove it on occasions. I just can't get the camera in there. I've never had an issue where I can't machine anything with a guard in place. I'm in the process of making more movies on tooling, work holding, cutting techniques, measuring equipment, the milling machine and other topics. I do hope that you enjoyed the video and got something out of it. I know there's a lot more involved, but hopefully, if you're going to buy your first ever machine and were a bit concerned that maybe some of your questions are answered, feel free to leave a comment. And thanks for watching.